All right, so this is for our lecture for February 1st. We're looking at our introduction to Forces Lab. In our regular classes, we're kind of doing this by going into the gym and we're identifying forces within motions there. For virtual, it's not as easy to go into, the gym and have all these guided lectures there. So we're having to resort to PhET simulation labs. So as we pull everything up, you've got to be able to make sure you read everything quite carefully because your instructions are also put into this document. So this is part one of a part two lab. You are asked a theoretical question. If that you are at the park with your friends and you have some rope and you're playing tug of war, and we have a total of 5 people. We can't have equal amounts on either side. So what would you think would be a fair way to split up your teams? And you would have to justify your answer. And you would kind of right here where I've highlighted, answer right in here. All right, and then following that up, our question becomes, what causes objects to move or stay still? And we have our link to our Forces in Motions PhET simulation. This link is also in the actual assignment for both part 1 and part 2. So you have to let it load up. And we're looking at net force first. You'll see motion, friction, and acceleration later on in part 2. So here we are. We have everything set up. We have sum of forces, which is our net force. Values are numbers, and our speed. So we went on ahead and we checked all of our boxes. So let's see what we need to do. All right, so we've selected our net force, our values, so that's perfect. Let's go ahead and split it up exactly what we see here. We see a bigger person and a smaller person in blue and a bigger person and a smaller person in red. So right here, here, and we have this person here and this person here. All right, so it looks like we have an equal value in each direction. Best thing about this being on the computer is we can definitely enhance the picture to see if it's true or not. And we can actually see 150 and 150 in either direction. All right, so we can kind of minimize this once more. All right, so we're going to make a prediction about the size and the distance of the direction. You'll press go and test the movement and record your observations. So let's go ahead. Let's press go and let's see what happens. All right, so we just saw they started pulling. Nothing happened in either direction. So we would simply take everything in our chart here. People are the same size, same distance. You had your predicted movement. Was there any movement? And we saw that there was none. Sum of forces right here at the top. We saw it was 0. Okay, and then you just kind of keep on going down. Do the same thing, manipulate your simulation and fill everything in here. So that would be part 1. Part 2, on the other hand, is a little bit more complex. So here we are in your Google Classroom. Part 1 is what we just went over. Part 2 is right here. It's starting off by asking you review questions. What is net force? What is friction? What is acceleration? And again, it's giving you a link. You're going back towards the forces and motions, and you are making sure that you are looking at the correct simulation. So we are looking at motion in this case. And make sure you are following the directions. Look at what they're calling for. Make sure to have your values, masses, and speed up, so that way you can record all observations and you can see what happens to each individual character. So as we are increasing our force, we see the speed is increasing. We see applied force in the direction is increasing. And we saw the person eventually lost control. We could place a person on top. So there's definitely a lot of different things that you can do here. So if you have any problems with your virtual lab or virtual assignment for today, please make sure to always go into your GoGuardian. You can send me a little chat message there, or you can go into your mail and just send me an email. But other than that, make sure y'all have a wonderful day.